Hello everybody. Right, we've got another exciting video for you this morning on this chap here. It's called a potentiometer, but it looks for all intents and purposes like a resistor, and it is a resistor. But instead of it being used to change the current in a circuit, we're using it to change the voltage that we get from a fixed power supply, or in this case, a fixed battery pack. This is a 6-volt battery pack. So 0 at the bottom and 6 volts at the top. And we're going to connect that 6-volt power supply to the left-hand side of this potential divider board. So there it is. That's our 6-volt supply. So we've got 6 volts on the left-hand side here. And the good thing about this use of a resistor is we've got a middle terminal here. And if I connect a voltmeter to that middle terminal, and I'll lead to the bottom, then by turning that little black dial, we can get any voltage we want from 0 volts up to the maximum voltage, which in this case should be about 6 volts. So let's bring that over. If I turn that little dial then as I increase it, we should see the voltmeter increasing. 0.1 volts, 0.2, 0.4, 0.6. That's 1 volt, nearly 2 volts. So by adjusting that little dial, if I adjust it halfway, then it should be about 3 volts, which is half of our power supply value. That's about halfway. And if I keep going, I am able to select the voltage that I require all the way up to, if I turn it up full, we get the maximum voltage from the battery in this case. There we go, up to about 5.78 volts. So a great little device. So because with a battery pack, you can only select either 1 cell, 2 cells, 3 cells or 4 cells. Whereas using a potentiometer, by turning the dial, you can select any voltage you want. So if I was looking for 2.8 volts, I just turn that little dial down until I get 2.8 volts. So a very useful little circuit for tapping off the exact voltage that you like. It's called a potentiometer because the correct name for voltage is potential difference. And it's the potential difference across these bottom 2 terminals here. Because I've got my voltmeter plugged in between this bottom terminal and this middle terminal, then it's reading the voltage across these 2 terminals here. So when we turn this dial, then what we're actually doing is we're sliding a little contact underneath the board. We're sliding it down for less voltage, or we're sliding it up for more voltage. Let's have a look at this on paper. Alright, here's our basic voltage divider circuit, which is 2 resistors, 2 series resistors sharing a 6-volt power supply. And if both those resistors are the same, in this case if they're both 100 ohms, then if we put a voltmeter across each of those resistors, then both of those voltmeters will read 3 volts because they have an equal share of the 6-volt power supply. But if we redesign the circuit slightly and we make the bottom resistor a 200 ohm resistor, then what will these voltmeters read now? Well, the bottom resistor's twice as big as the top one, so therefore it will get twice as much of a share of the voltage. So in this case, 4 on the bottom, 2 at the top, and they both still add up to 6 volts. So the bigger the resistor, the bigger the share of the voltage it gets. Now, we can do the same thing with a single resistor. If we add a single voltmeter, but that voltmeter's got a sliding contact, and that sliding contact can go from the bottom of the resistor, we'll call that position A, up to the top of the resistor, position B. So if the sliding contact can move up and down, at position A, the voltmeter's going to read 0. And that's because the voltmeter isn't covering any of the resistor. But as you slide it up to position B, then the reading on the voltmeter is going to increase.
and that's because the voltmeter is across more of the resistor. And when the sliding contact is directly in the middle, then this is the same as a voltage divider with two equal resistors, top and bottom, just like in our first example. So the voltmeter reads 3 volts in the middle because it's got equal resistance below it and above it. The voltmeter in a potentiometer is effectively measuring the voltage from position A up to where the sliding contact's position is.
Now if I add a transistor to the potentiometer, then that transistor is an automatic switch and it's got a wee LED beside it. And if I turn this dial right down, the transistor is off and the LED is off. Watch what happens when I increase the potentiometer. The LED comes on. If I turn it down again, LED goes off. But the question is, what voltage does that happen at? Remember, with this dial right down at the bottom, pushes that arrow down to the bottom of the resistor and we get 0 volts. As we turn that dial up, we increase the voltage we're getting from the power supply to whatever value we like. So the question is, what voltage is required to turn on the transistor and turn on the LED? Let's put a voltmeter in. Here's my voltmeter here. And we'll put the voltmeter at the base of the transistor. The base of the transistor, that little letter B there, if you follow that back, it takes you back to this red terminal. It's the voltage here that turns on the transistor. So let's see if we can watch when the LED comes on. And we've got our voltmeter here that's reading 0. Watch for the LED coming on and watch the voltage. Turning up, turning up. Voltage is increasing, it's at 0.3. Turning up, it's at 0.5. LED's not on yet. Turning up, turning up, turning up. Points, LED is on. The LED is on and the voltage is 0.7 volts. If I turn it down again, LED goes off. The reason for that is that a transistor conducts when the voltage to the base of the transistor is more than 0.7 volts. Let's go down again. There's 0.6, the LED's off. So the transistor is off when the voltage at its base is below 0.7. If we go to 0.7, LED is on. If we go above 0.7, if we go up to 1 volt, or 2 volts or 3 volts, doesn't really matter. Your voltage can be as big as you like. And the LED will still be on because the transistor's on. The transistor switches on when the voltage at its base is 0.7 volts. Why 0.7 volts, you might ask? Well, a transistor is made of silicon. Silicon's a kind of strange element. It behaves like an insulator. But if you put a voltage up its backside at its base terminal, you can make it conduct. You can force it to conduct. And the voltage at which that happens is 0.7 volts. 0.7 is the magic voltage.
That's it. See you in the next one.